Right, so let's just create a sphere, just do a demo something. Let's create a polygon. Let's up the thing, and let's animate this thing. Right. So let's just say $T or something. So I just move upwards. Right. So, and now let's make a mount, like a attribute of up. Just add some noise in here. Just do turbulent noise. 3D noise. Position. All right. Let's just do it in here, just a little bit. All right. So what will happen now if I play is that you can see that because the sphere is moving and the noise is being applied afterwards, you have this noise flowing through the geometry. And that's also what's going to happen if we triplanar map displacement noise inside of our shader or like whatever we're going to map. So that's not ideal. And I mean, I know that's going to happen, so we can already take care of that like before it happens. So what you can use for something like that is a rest position. So what a rest position is like similar to what we did here with the point deform. It's just a time frozen position, so just a non-animated position. So let's say if we make a time shift in frame 1. So let's make a time shift on our animated sphere. So now this is not happening here. Now we can say that we want to copy an attribute, so not transfer an attribute. So if the point count remains the same, you can actually copy attributes. So then we'll just match the attribute to the point number. So let's copy an attribute. And on the time shift here, we want to put a rest position. So this will put down an attribute called rest. So you can see rest 0, 1, and 2. And all this is doing is just, if I type make a wrangle and type v at rest equals at p, that's just what this is doing. Exactly the same. But oh, it's a hard-coded thing. I thought maybe they were doing that under the hood. So it's doing exactly the same. So let's remove that. So, but this will not change. So this rest position will remain constant. So here we have this moving noise. Not ideal. But what we can do is, instead of plugging the position in here, what we can do is type bind rest, make it a vector. And instead of putting the position in our noise, we're gonna use our rest position. So let's see why this is not working. Oh, we need to copy, of course, our rest position. So copy our rest position. And now you can see it still works because we binded the rest in it. And now if I play, you can see the noise is not floating. It's because right now we're driving this noise based on our rest position. And our rest position doesn't change. It's just, this is our rest position, copying it to our geometry, and then we're driving it over there. So we're going to be rendering in Redshift later, and Redshift recognizes the rest attribute if it's there, and then like stuff like triplanar mapping will just keep the rest position into mind when applying. So just something to keep in mind. So what we can just do in here is just attribute copy, copy a time shift, put it on there, copy the rest to it. And now we have a rest position on our object here. So it should have a rest. Oh, forgot to copy the rest. So now you can see we have a rest position. That's all we need for this to be able to use triplanar down the line. And in this case, this triplanar is just a lot easier because we don't need to specifically say where certain parts of a texture need to go. We just need to be able to map a procedural texture on this thing. We're going to use triplanar basically everywhere because the entire scene that we're building is procedural. So we're just going to use triplanar for most of the stuff. So yeah, I guess we could move up a level now and just have a look. And this is basically our little squid. So it looks a little bit different than the original one, but this is because just the parameters are a little bit different. So I like my original one better. Not sure why this is not animating right now. Let's go down here. Because of course with my original one, I really tweaked the parameters to sort of make it look like the way I wanted to. But yeah, you can download this file, of course, and have a look through it. But that's basically how the squid was done. And of course, you can apply these techniques to create any type of sort of cool procedural models or whatever you want. So I really hope you found this interesting. We covered a lot of cool techniques. So let's just quickly go through this whole thing again before we round this up. And again, we're going to add more attributes to this thing later once we start diving into the shading, when we're going to do the look, because that's generally how I work. I just make something, and then when I decide in the shader that maybe I need some extra attributes, I will generate them at that time to cover whatever I need, because you might not know initially exactly the look you're after, or unless you, of course, you have concept art. But in this case, let's just do it later. So let's just walk through the thing again. So what we did, created a line, and we copied circles to it. We made a skin from it. From the same thing, we created some lines. The direction of the lines was created by a normal that was importing a point attribute from a second input, and then subtracting from the position to create a normal. Then we're doing noises with the flow noise. Then we are sort of carving those and then scattering stuff on it to create these weird things. Over here, we're just using polywire to create these things. Over here, we are using a for each loop. First time that we use that to scatter points evenly across the thing, and then we're using a point deform to sort of move them along with our rest, with our animated stuff. And again, we sort of did a time shift here because else the scatter would sort of bounce around, which we didn't want. Then we did some quick maths here with the cross product in order to determine a vector that would be facing inward. Oh, I think I removed the marker, but this is what we did to sort of move these things inward. So merging it with the original thing. Then the eyes, just scattered points based on density, like we did with the seaweed. The noise is being used to drive a normal. So just animated normals, and those animated normals will be used to copy eyes. So we get nice animating eyes. Then this whole thing that we made for the the eye itself, of course, what we did is just a simple UV unwrap. Then what we did for the base mesh here is just extruding it inwards a little bit, creating VDB from polygons to get more detail on it. Attribute transferring a color, then insetting the whole thing based on the normal, and then multiplied by the attribute, so we get these inset stuff. Then adding flowy noise, and which is referenced in the eyes as well, so they move in the same rate. And then everything merged together, copying rest attribute, and then we're left with a very cool creature. So yeah, hope you found this interesting. So now I hope you join me in the next video, which is going to cover more procedural assets like the rocks and the coral and a whole lot more stuff. So going to be super excited. This was the most the biggest assets that we had to build. The other stuff is a little bit simpler, but yeah, we're slowly starting to get to a pretty cool thing. So hope you found it interesting, and hopefully see you in the next video.